Welcome to this video. My name is Darshan M.Katgeri and I am working with Jain College of Engineering, Tehran. In this video, we will be solving a problem on hexahedron, which means a cube. Hexahedron is also called as a cube, which is a solid in which all the faces are squares. So let us read the problem. A hexahedron of 30 sides is resting on one of its corners on HP. It is resting on corner, so it is important to note this, such that one of its solid diagonals is perpendicular. Solid diagonal is perpendicular. This is important. Draw the projections. Note that in this the axis length is not given. The inclination with respect to the horizontal plane is not given. The inclination with respect to the vertical plane is also not given. It is only mentioned that it is resting on one of the corners on HP and the solid diagonal is perpendicular to VP, and the dimensions of this hexahedron, that is the cube, are given. And we are asked to draw the projections of the solid. Projection means the final front view and the final top view. We have to draw these views. So let us go to the visualization and try to visualize what is being asked in this problem. So it is a cube. That means all the faces in this, you can see that there are two blue colored faces in this, two orange colored faces, and two faces which are yellow color. One is on this side and the other one is on this side. So there are altogether 6 faces. One is the top face, one is the base, and 4 lateral faces, and all of these are squares of 30 millimeters. ABCD forms the base. B is behind here. Point B is behind. This point is B. And PQRS is the top face, and all these faces, that is 2 orange and 2 yellow faces, form the lateral faces of this cube. So in the top view, we can observe like this, and in the front view, it is observed, it is seen like this. We can see 2 faces as seen, and this edge represents edge SD, and edge QB is behind the edge SD, okay, as it is seen in this particular visualization. Solid diagonal. If I join this corner P to corner C as shown in this, that is corner P to corner C, it is a solid diagonal. Also, if I join A to R, that is also a solid diagonal. Also from S to point B is also a solid diagonal. Also from D to Q is also a solid diagonal. But we are going to consider the solid diagonal PC to solve this problem. Also take note that this problem, this diagonal, solid diagonal PC is parallel to the vertical plane. You can see that in the top view, PC is the diagonal, and that diagonal is parallel to the vertical plane. We can also consider diagonal AR and solve this particular problem, but I'm going to solve this by considering the diagonal PC. So let's go back to the presentation. We will start the problem by drawing the XY line, marking VP and HP, and it is resting on one of the corners on HP. So we need a corner. In this case, what I plan to do is I'm going to rest it on corner A. So we need one corner. So in the top view, we have to draw it like this. That means this has to be drawn at 45 degrees. The square has to be drawn at 45 degrees. So this angle is 45 degrees, and you draw one line at 45 degrees here, and you mark 2 points, and with respect to this line we can construct the square. The sides of the square are 30 mm, and name it accordingly. ABCD is the base and PQRS is the top face. So the base is put in brackets. So you can see that ABCD, all these points cannot be seen, so they are put in brackets. Now we have to draw the front view. To draw the front view, you take the projections and mark the axis. The length of this line, that is the axis, is 30 millimeters. So mark 30 millimeters and dimension it, and complete this view. So you can see this edge is drawn here, this edge is drawn here, this is the top face, and here we have two edges. Those two edges are SD and QB. So you can see that S dash D dash and Q dash B dash corresponding points in this front view. So once you draw the initial views, now we have to consider the solid diagonal, that is P dash C dash. So consider the solid diagonal. Now this view has to be reconstructed here. So to reconstruct this view, we are going to draw one line, that is from A dash to S dash Q dash. This line will be perpendicular to the solid diagonal. Okay, so at point P you can see that this line A dash S dash Q dash, it is perpendicular to P dash C dash. It is at 90 degrees to this. This is required because this will help in construction. So if I show you the visualization, and if you see the front view, you can see that this line, this particular line, this point is on this surface. This is the midpoint of the top surface. It is not passing through this point or this corner here or this corner here, but this line that you have drawn, which is at 90 degrees to the body diagonal or the solid diagonal, is passing through the center of the top surface. We can measure and see this. I'll measure and show you. You can go to the protractor tool, and at this point it has to be 90 degrees. So you can see the angle here. It will appear if once I measure the angle. So with respect to this line, the angle is 90 degrees. You can see that 90 degrees appears here once I have this. So it is at 90 degrees to this. That is, this particular angle. This particular angle is 90 degrees, and it is passing through this corner and the center of the top surface. The center of the top surface, and it is perpendicular to the body diagonal. So as it can be seen in this particular view. So this is what we have drawn now. So this is what we have drawn. Now we have to reconstruct this. To reconstruct this, we will consider a point. I'm going to rest it on point A dash. If I see this, I'm going to rest it on point A dash. That means I'm going to rotate it anti-clockwise like this. So we can mark a point A dash. Say this point A dash, you mark this point A dash first. You can construct this line later. So first thing, you mark this point A dash and you draw one line. The length of this line is equal to A dash S dash Q dash. So, and you have to mark point E dash also because it is required for construction. So you measure A dash E dash and you mark from this point A dash E dash. You draw one arc, and at this point you draw one line perpendicular to this line. Okay, so next you can measure E dash to P dash and mark this point here. Next E dash to C dash and mark this point here, and thus you can obtain this line. So this line, that is P dash C dash, P dash C dash, can be drawn. This will be parallel to the XY line. So once you draw this, you can draw other points easily. I will explain how to draw the points. So now you will have point P dash. From P dash we can measure R dash. From P dash we can mark R dash, measure R dash and mark an arc here. And from C dash we can measure R dash. From C dash we can measure R dash and draw another arc. So you will have two arcs. So if we join these points, we will get the outer boundary of this. And to draw this edge, you take the measure from P dash S dash, P dash S dash and mark it here. Similarly mark it here also and join this line. Thus we obtain this particular view. Construction is easy. You can just try the steps that I have explained. Then we have to now obtain the top view. To obtain the top view, first we have to take all the vertical projectors and the horizontal projectors. Yeah. Next step is to identify the hidden and the visible edges. You can see that this point A dash, this point A dash is the farthest point from the observer. Observer is standing here, so you will be watching from here. A dash is the farthest point. So whatever is starting from point A here, corresponding point to A dash is point A here. Whatever is starting from that particular point will be hidden. So what is starting from point A? To identify that, you should come to this particular view and see that from A we have AB, AD and AP. From point A we have AB, AD and AP. So these three edges are starting from point A. So this is what we are talking about. Just explaining this. So this is what is being drawn, and now we have to draw this and we have to identify the hidden edges in this particular view. So you can see that A is the farthest point. So whatever is starting from A, that is AB, which is on this side, and AD and AP are not visible to us in the top view. So the same thing we have to identify here. A is the farthest point, so all the points that are starting, all the lines that are starting from this point are not visible to us. Point R is the nearest point. You can see that point R is the nearest point. So whatever is starting from R is visible to the observer. So RQ, RS and RC are visible to the observer. So RQ, RS and RC are visible to the observer. And this is how you need to draw this view. Boundary lines are always visible. So PQ, QB, BC, CD, DS and SP are visible. Boundary lines are always visible, so you must take care. Now we have to reconstruct this here such that the solid diagonal should become perpendicular to the vertical plane. In this view, the solid diagonal is parallel to the vertical plane. You can see here in the front view, you can see that it is parallel to the horizontal plane. In this view, that is the initial view, it is not parallel. We have made it parallel to the horizontal plane, and at the same time it is also parallel to the vertical plane in this particular view. But what we want the solid diagonal is perpendicular to the vertical plane. So now we have to make this perpendicular. Here it is parallel. PC is parallel to XY line. We can see that clearly in the top view. So PC is parallel to XY line. This has to be made perpendicular. That means this has to be rotated. Okay, such that PC becomes perpendicular to the vertical plane. It becomes perpendicular to the vertical plane. So to do that, what we will do is we will draw one vertical line. I will just go through this and explain this. Yeah. Yes. So we have to draw one perpendicular line. How to reconstruct this I am explaining. Draw one perpendicular line. Mark point C here on this perpendicular line. Then you can mark all the points. Measure CR, cut an arc on this particular line which is drawn. Then measure CA, cut another arc. Measure CP, cut another arc. So you will have points C, R, A and P on this straight line. Then you can measure CB. Observe that CB and CD are of same length. So measure CB on the compass, and from C you mark B, draw an arc here. At the same time you can mark arc D also because they are of same length. Then you will observe that RQ and RS will be of same length. So from R you can mark another arc here, and from R you can mark another arc representing this particular point S. So we have these points, but only one arc is not sufficient. We need two arcs to locate a point. So one more arc can be got from this particular point P. So we can measure PQ, and from P we can cut another arc. So you will have two arcs which intersect each other. And similarly we can have PS. So we can draw another arc from here. So we have two arcs intersecting. So similarly we have to obtain all the points. Once we obtain or reconstruct this, then now we have to go for the final front view. This is the final top view. You see that in this view PC is parallel to XY line, but in this view PC is perpendicular to the XY line, which is what we want, because we want the solid diagonal to be perpendicular to the vertical plane. Okay. So once we obtain this, now we have to get the final front view. Steps are the same. We will first bring all of this and explain to this. Yes. So mark all the points you can see here. First let us mark ABCD. A is here, corresponding point A dash is here. So this point, wherever they meet, that will be the required point A dash. Similarly B is here, so you draw one line from here, and B dash is here. So wherever they meet, that point is B dash. Similarly you mark all the points. C from here, they meet here. D from here, they meet here. And next PQRS has to be simultaneously obtained. From P you draw one line, and from P here you draw one line, and obtain all the points likewise by drawing the projectors. You will see that point P and C, they are point P and C. Let's go to the next scene. Yes, this one. Point P and C. C is exactly behind point P, as it is seen in this particular view. Point P is in front and point C is behind the point P. Okay, so they appear as if they are on the same point here. So this point represents point P dash also and C dash also. But C dash is the point on the base. You can see here A, B, C, D. In the front view we are calling it as C dash. So this C dash is on the base and the observer is standing here, right? So C dash is the farthest point from the observer. So whatever is starting from C dash will not be visible to the observer. What all is starting from point C, edge C, B and CD and CR. These are the points that are starting from this point. So you can come to this particular view, that is the initial view. CB, CD and CR are the three lines that are starting from point C. So those lines have to be drawn, and those lines will be dotted lines. You can see that C dash B dash, C dash D dash and C dash R dash. These are the lines which are not visible because they are starting from the farthest point. But P is the nearest point, that is corresponding point P dash here. P dash is the nearest point. You can see in this, P is the nearest point to the observer. Observer is here. So whatever is starting from point P will be visible to the observer. So PQ, PS and PA, these are the lines that are visible to the observer. If I switch off this mode, it will be much more clear. You can see PQ, PS and PA, these are the lines which are visible to the observer. So in this you can see that what is starting from P, PQ, PS and PA. So whatever is starting from P, that is corresponding point P dash here, P dash, Q dash, P dash, S dash and P dash, A dash. So these are the points which are visible, so they have to be drawn by continuous lines. So this is the complete solution. Let me just show you the visualization once again. So this is what we have drawn. Again, I will just reiterate the steps. First, draw the hexahedron in this orientation, that is, it is at 45 degrees as seen in the top view. So this angle has to be 45 degrees. Next, rotate it such that it is resting on the corner, and the solid diagonal in this particular view becomes parallel to the horizontal plane, and in the third view the solid diagonal is now made perpendicular to the vertical plane, which you can see. That means if you draw one line starting from PC, if you extend the line, that line will be perpendicular to the vertical plane as it is seen in this particular figure here. So this is how it is. So this is the visualization. See the complete view once again. Let us put off this mode. So this is the front view, that is these three views here. So compare this with this. So this is what we have drawn, right? And the top view, like this. Let us go back to this and you can compare the top views here. So this is the complete solution, and this problem may be solved in the grid sheets.